So let's talk more about the TVM solver and solving investments with regular payments. Okay, best way to do this is just to do examples, since it's pretty similar to doing any other kind of TVM solver question, just with a couple exceptions. Okay, so we've got this new question here. So it says Paul is now 18 years old and he needs money for his education. On his 14th birthday, so when he was 14, his family deposited $1,000 into an RESP, a registered education savings plan, at 3% interest compounded annually. Since then, this is the new part, he has deposited $1,000 of his own money into the account each year, so once a year. How much is the account worth now? So the future value. So let's take a look here. So we're just going to do the same kind of outline we did before. So we've got our n, which we're going to save to the end. N for end. I percent, which we know is 3%. Then we also have our present value, which is the money that they started with. So it's $1,000 that went away into the bank, so it's negative. The payments. So now that we have a payment, we actually get to use a payment. Okay, so just like your present value that goes away from you into the bank, each of these payments is also going away from Paul into the bank, so they're negative, right? And he pays $1,000 each year. And we also have the future value. Future value, we don't know. That's what we're looking for. The payments per year says that Paul made one payment per year, so we have a payments per year of 1. And a compounds per year, this was an annually compounding investment, so that's a 1. Okay, to find our n, we have compounds per year times years. Okay, between his 14th and 18th birthday, that's 4 years. So 1 times 4 equals 4. Okay, so let's stick all our values in here. So we have an n of 4, so let's just stick that there. We have an I of 3. Whoops, that's not 3, that's 9. Present value of negative 1,000. No. It's not cooperating. There we go. Again, just tablet issues here. Okay, and then we just get negative 1,000 for the payment as well. Future value, we don't know, we leave it alone. Whoops. Again, just a tablet issue, not one you should have. So future value is 0 for now because we don't know it. Payments per year is 1 since we make one payment a year, and compounds per year is 1 since we make one compounding period a year with an annual investment. So we solve for the future value here, just go clicking on this button, doop, and we get, so that equals $5,309.14. Which, if we think about it, makes sense because there was that initial $1,000 plus 4 other years of $1,000 each. So 1,000 plus 4,000 is 5,000. So that $309 is how much he made. Right? So if we were to ask, how much interest was earned, as in what was really the point of investing this money, how much money did you actually earn, we know that we have now $5,309.14. And we know that if we just, put the money in a bag somewhere, we would have had that 1,000 initially and the 4,000 over 4 years, so 5,000 in total. That was invested over that entire period, giving us an interest of $309.14 rather. Okay, so that's how much money was actually earned just by sticking in the bank. That money was just profit. Okay. So obviously that number grows the longer you leave it in there, but hey, that's not bad for 4 years. So here's another example that might apply to you, or might not, but it will still apply to you in terms of budgeting. Okay, so let's say you want to save up for a PS5. With taxes in, it's worth $711.89. You want to buy it by this time next year, assuming that's when they'll be available, and you find an investment account for 3% compounded quarterly. Remember, quarterly means 4 times per year. Assuming you start with $100, that's how much you got right now, how much would you have to invest monthly, so how much do you have to put in the account every month to meet your goal? Okay, so this is a common kind of question because it's setting a goal financially and figuring out how much do you have to take out of your budget to afford that goal in the time that you want to afford it, right? Very rarely are things bought just out of pocket. You very rarely have just this cash lying around. You have to think about where you're spending your money and how long you need to save your money to get the thing you want. Okay, so we treat it just like every other question. N equals, we're going to do it at the end. I%, we have a 3% interest. Present value, as stated in the question, we get $100 to start. Okay? But remember, we're giving this into the investment, so that's negative 100. Okay, our payment, PMT, well, we don't know that, right? This is what we're finding. Our future value, we want it to be equal to the amount that we need for the PlayStation, so $711.89. Okay, now the payments per year, we said we are making monthly payments. I like to choose monthly because it's a more realistic goal. A lot of bills are monthly. It lets you budget a lot simpler. Things like rent, utilities, cell phone, all paid monthly. So if you're thinking about when your money goes out, monthly is a good way to do it. So payments per year is 12. And compounding periods per year, this one, again, quarterly. I like to think about it like 4 quarters in a dollar. So there's 4 quarters in a year. So that means it compounds 4 times per year. Okay, so our N, we've got our compounds per year times years. Okay, which gives us 4 times, we want this done in 1 year, so 4 times 1 is 4. Okay, so there's all of our variables stuck in there. So now all we got to do is we just got to stick it in the calculator and see what we can find. Okay, so N is 4, I is 3. Present value is our 100. Okay, payment, don't know, got to leave it alone. Future value is going to be, this is positive since it's coming back to you, $711.89. Oops. Right. Payments per year, we're making 12 payments per year. Compounding periods per year, we're making 4 compounding periods per year. Okay, so we hit this button, we should figure out what our payments need to be every month. So $152.15. And if we think about that answer, it doesn't make sense, does it? Right? Because if you take, because if we paid $150 12 times, that's way more than the price we needed. So here's the thing. When these two numbers are different, we use the payments per year, not the compounding periods per year, up here. Okay? Now, was this a mistake on my part? Probably. Are mistakes okay to make? Yes. Okay? So we just fix them, making sure to check our answers so that they make sense. Okay? So if we change our N to 12, we will find that our answer makes a heck of a lot more sense. $50. Right? So our answer for the payments is to make $50 payments and 5 cents. Whoops, not 50 cents. And 5 cents at each period, so each month. Right? So that means that if you save $50 and 5 cents every month over that course of that year, with this interest rate, you will have the money you need for that PlayStation. Okay? So that is just the basics of using the TVM solver with payments in an investment for the purpose of either saving or for the purpose of, well, next time we'll look at paying down loans.